Bonjour, mateys. 5.7 is systems of linear inequalities. So when we're solving systems of equations, you got two lines and you look for the point of intersection. When you have a system of linear inequalities, you're going to have one graph that's been like shaded on half, and then another graph that's been shaded on half. And it's the solution is the overlapped shaded area. It's all the points in the overlapped shaded area. So that's what we're going to do here. So systems of equations have one solution. Systems of inequalities have tons of solutions, but you got to find them. And it's going to be by graphing two inequalities and finding out where they overlap. Okay, so this is some vocab that we're going to use. Feel free to pause this and jot that down if you want. Let's jump into some notes for you. Woo! So a system of linear inequalities is a set of two or more linear inequalities using the same variables like x and y. So here's an example. So we got one that's y is less than x plus 2, and another one that's y is greater than or equal to 2x minus 1. A solution of the system of inequalities is an ordered pair that is a solution to both inequalities. Okay, and there are lots and lots and lots of possibilities. So feel free to jot that down in your notes. You might also want to include, and I think this is coming soon in the notes, that a solution is also where your graphs overlap. It's the overlapped shaded area. So, but the first one, they're going to give us some points. We have to decide if these points are solutions to this system or not. So let's say here's our inequalities. Y is less than 2x. Y is greater than or equal to x plus 1. So you have to decide if x is 3, y is 5 is a solution to this system of inequalities. Okay, let's see how you did. So you plug in 3 for x and 5 for y, but you have to do it in both inequalities. So when you plug it into the first one, it works because 5 is less than 2 times 3. 5 is less than 6. That's true. Yay. You also have to plug in 3 and 5 for the second inequality. So you plug in 3 for x and 5 for y, and you get 5 is greater than or equal to 4. That is also true. Therefore, 3, 5 is a solution. I think it's going to state that. Look at that. It is a solution to this system of inequalities. That will be in that shaded area where those two graphs overlap. All right, same inequalities. See if negative 2, 0 is a solution to this system of inequalities. Okay, I'll go quickly through this one. So you plug in negative 2 for x and 0 for y, and you will find out that it works for one of the inequalities, but not the other one. Therefore, it is not a solution because it has to work for both of these inequalities. Okay, take a look at that. Make sure it all makes sense before we move on to the graphing part of this thing. Okay, so when you're graphing a system of linear inequalities, you're going to graph one of them. Here's the thing, though. Shade it really lightly, okay? So let's say you're going to graph y is less than x plus 2. You got the dotted line that matches this equation, and it's going to be shaded below. It's this blue shading here. And then you got this other one, this y is greater than or equal to 2x minus 1. That's this red one. And this one's going to be shaded above. The solution to the system of equations is only this purple part. It's only the overlapping part. So all the points in this purple area are ones that fit both of these inequalities. These are where the solutions are. Okay, the blue ones only work for the blue equation, inequality. And these red ones up here only work for the second one. The purple ones work for both. Yay! Anything on the red line also works. Anything on this dotted blue line, though, doesn't work. Okay, so it's this purple area excluding this dotted blue line. And if you need some clarification on that, ask me during class. This is a great thing to take some notes on, especially if you have some colors. If you don't have colors, only shade in this purple part on your paper so you know that that's where the solution is, just the purple part. Okay, let's jump through some quick examples. I'm just going to be clicking through. So if you're going to graph this system, y is less than or equal to 3, you're going to have a graph, and you're going to put a solid line going through 3 and shade everything below. Do this super lightly because this isn't your final answer. And then you're also going to graph y is greater than x plus 2. That'll be a dotted line because it's only greater than. and this y is greater than x plus 2, you could try the 0, 0 test. The other way to think about this is if you have y by itself and it's greater than, you're going to shade above. If y is by itself and it's less than, you'll be shading below. So in this case, you're shading above that line right there. This purple area is the solution set. So this area right here is where your solutions are. Not this red part, not the blue part. Just the part where it overlaps. Okay, and then any point from that purple section, like -3, 1, will work for both of these inequalities. And I think they're showing that right there. There you go, they're verifying it. So if you take a point from the shaded region, the overlapping shaded region, like -3, 1, you plug it into both of these, you'll find out, oh, it works, yay. And there we go. That's a solution, is this whole shaded part and any point inside that shaded part. Okay, let's go through another example. So here, if it's in standard form, you first want to rearrange it so that you get y by itself, or not. Apparently, they're just, jumping right to graphing. So if you're going to graph these without Desmos, you'll want to get y equals mx plus b form. So this one, subtract 2x on each side. You get y is less than -2x minus 1, so that's why the y-intercept's -1, going down 2 every time. It's a dotted line because it's only less than. And then you're also going to graph the other one. Also a dotted line, shaded the other way. Ooh, okay, here's a question for you now. One of the few in this ed puzzle. Where do these overlap? You're right, they don't overlap. Therefore, this has no solution. There's no point where these two graphs overlap. So there's no numbers you could plug into both of these and they would both be true. There you go. So sometimes you will have no solution if there's no overlapping area. Okay. Moving on. Here, they give you a graph and you have to identify what the system of inequalities ends up being. So for this one, we got a line at y equals -2, and it's everything above that, clearly, because that's where the overlapped shaded area is. So one of our inequalities will be that horizontal one, y is greater than or equal to -2. And then the other one, we got to find the slope and y-intercept. It has a y-intercept of 0 and a slope of 1. So it's going to be y equals 1x, but not equals. It's a dotted line shaded below. So it's y is less than 1x. And there we go. So that is our system of inequalities. Okay, look this over, make sure it makes sense. If you have questions, make sure to ask me in class. And now we're going to jump to another example. It's the same idea. So here, if it's a straight vertical line, your equation is going to be an x. So here, x is less than or equal to 3. You know it's less than because it's shaded to the left. And then you have this other one that's going to be a y equals mx plus b type form, shaded above that. So it ends up being y is greater than 2/3 x, because your slope is up 2 and over 3 on this dotted line. And the y-intercept is -1 right here. And it's greater than because it's a dotted line shaded above. So that is our system of inequalities there. All right, so look at that. Again, if you have any questions, make sure to ask me in class. I know I'm going kind of quickly here. So if you look this over and it doesn't make sense, ask me about it. And then, of course, you're going to have some word type problems. So if you have at most 8 hours to spend at the mall and at the beach, and you want to spend at least 2 hours at the mall and more than 4 hours at the beach, this will be actually a system, quite a complicated system. So we're going to have x and y have to be, if it's at most 8 hours, x plus y has to be less than or equal to 8. And then let's say x is the number of hours at the mall, and it says you're going to spend at least 2 hours at the mall. Therefore, x has to be greater than or equal to 2. If you're going to spend more than 4 hours at the beach, that means that y has to be greater than 4, because it can't equal 4, just more than. So this will have an overlapping area going over 3 of these graphs here. So first, you got that one. That's the x plus y is less than or equal to 8. It'll be shaded below. X is greater than 2 will be this line shaded to the right. And then x or y is greater than 4 will be that dotted line shaded above. So the overlapping area is that little triangle right in there. That's the one area where all 3 of these shaded regions overlap. Okay, so that's how you do it if you have more than 2 lines, is you have to find the overlapping area for all 3 lines if you have 3 lines. Okay, I know that was fast. I didn't ask you a ton of questions. It's probably still a long video. Anyway, if you need some help, let me know during class. I will see you then. Arr!